All right, so here we are with activity one. Again, these activities are tricky. I recommend trying them on yourself, but if you need some help, that's what these videos are for. I'm going to try to go through these in some detail a little bit faster than a normal exercise video, because you might need some explanation. So and by the way, these are taken from an algebra book by Kathy and Bruce Yoshawara, which are some of my favorite textbook authors who used to teach at Pierce College, but they're retired now. So anyways, we're going to look for -5, 3, and 3, -9 here. 1, 2, 3, 4, 5. 3 is right here. And 3, -9 is right here. So those are those 2 points. And then we're going to draw the line segment joining them like so. What we're going to do is figure out the length of that line segment. That's what the goal here is. So then but first, before we get to that part, we're going to draw horizontal and vertical line segments to make a right triangle. So here's a horizontal one and a vertical one. That, because one is horizontal and one's vertical, we made a right triangle here. So that's a right angle there. Now, let's get the coordinates of the vertex, or the corner, at the right angle. So let's see. This one has the same y coordinate as this one, so the y coordinate is 3, and the same x coordinate as this other point, so that's also 3. So that's 3, 3. Just label all those right here. So let's find the length of each leg. We'll call those legs A and B. So let's say the horizontal one here is A, and this one is B, the vertical one. So if you want to find A, how would you find that length? Well, you could just count like 1, 2, 3, 4, 5, and then 1, 2, 3 more. So it's 8. You could just count it that way. So it's going to be 8. And then B, you could count it. Oh, sorry, that's supposed to be -9. You could count up 9 here, and then up 3 more. You would count 12 units. So those are 8 and 12. But let's look at this thing on the side here. Do you see how to calculate A and B from the coordinates of the given points? So how do you get A by doing subtraction? Well, if you take the bigger x coordinate here, this x coordinate here is 3, and you want to know how much does x have to change to go from 3 to -5, that distance is 3 minus -5. Just like you do when you're finding the change in y or the change in x when finding the slope. So 3 minus -5 is the same as 3 plus 5, which is 8. And same thing with B. If you want to know how far apart these x coordinates are, sorry, these y coordinates, I meant to say, you could take the bigger y coordinate minus the lesser y coordinate, which would be 3 minus -9. I just realized that's cut off from the bottom of the screen. Sorry. 3 minus -9 is 12. It's the same thing as 3 plus 9. So that's how you can get it by doing subtraction with the coordinates of the points. So now let's use the Pythagorean theorem to calculate the distance. Now that we know the legs are 8 and 12, we can use a Pythagorean theorem by saying one leg squared plus the other leg squared should be equal to the hypotenuse c squared. Because when we talk about the distance from this point to this point, you're talking about like going there in a straight line along the diagonal. Like you could get there by going along A to B, but that's not really what you mean by distance. You want to measure in a straight line. So that's the c that we're trying to find here. So let's see. 8 squared is 64. 12 squared is 144. that's equal to c squared. 64 plus 144 comes out to be 208. And you could get the square root of that. And let's see, the square root of 208 is about 14.42. Okay, so that's how you can get the distance basically between any 2 points. Now, what if, for number 2, what if you wanted to do this in general? What I mean by that is, like, what if you don't have a grid and you don't want to go through this whole process of, like, drawing the points and counting out how far over they are? Like, what if there was just, like, a nice formula that you could plug the numbers 3, -5, and 3 and -9 into to get that distance? That's what we're going to figure out here. So for this one, plot any 2 points you want, but try to follow along with what I'm doing with your own points. I'm going to just make a random point somewhere over here and a random point somewhere over here. It doesn't even need to be on the grid. Because what we're going to do is we're going to label this as x1, y1, and this point is just x2, y2. And we're not going to actually use the specific numbers. I mean, it looks like x1 is about -6.5 and y1 is about 7.5, but we're going to pretend that that we don't actually know what they are, so we can do this so we're going to get a formula for the length just using the values x1, y1, x2, y2 as if they're like variables here. So we're going to draw the line segment joining them like so. Okay, that's what we're trying to find the length of. And in order to do that, I'm going to draw a vertical line here and a vertical line here. So this is now going to be where the right angle is, because that's a horizontal and vertical line. I think I said vertical at one point when I meant horizontal here. Anyways, what are the coordinates at the vertex of the right angle? Let's answer this question here. So let's see, because we went down vertically here, this point must have the same x coordinate as the point up here, right? It looks like they're both about -6.5. So that's x1. And y2 is the same over here, because if you go horizontally, these both have a y coordinate of about 3.1 or whatever it is. So this point is x1, y2. Now let's find the legs A and B. I'm going to let B be the vertical one and A be the horizontal one. It doesn't really matter which is which, though. So if you want to know how long this is, how long is A? Well, just like we did before, that distance is the same as if you find that distance along the x-axis. So whatever that distance is between those x coordinates, so this is x1 here and x2 here, if you just subtract the bigger number minus the smaller number, you'll find out how far apart they are. So this is just going to be x2 minus x1. And same thing with the B distance here. You want to know how far apart that is. This distance here is going to be the same as this distance here. Just realize this is a good spot for a highlighter. This distance here is the same as this distance here. So let's see, this x coordinate here is y1, sorry, that y coordinate there is y1, and this y coordinate here is y2. So how far apart are they? You could just do y1 minus y2. And you could also do, I want to write this a slightly different way. I want to write y2 minus y1, which is a negative number because y2 is smaller, right? But then what if you take the absolute value of it? If you take absolute value, it doesn't matter which one is bigger. The absolute value of one thing minus another thing is always the distance between those numbers. Remember from Appendix F.1, we talked about absolute value a lot that way. So that way it doesn't matter which way you subtract them. Okay, so now that we have that, let's use the Pythagorean theorem to calculate the distance between x1, y1 and x2, y2. Well, let's see. What we're going to do is we're going to say this absolute value squared, like a squared plus b squared. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared, right? We're trying to find that distance, and we've got this, the b is that one, the a is that one. Well, let's just plug that into the theorem here. So we're going to take the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared. That will equal c squared. And at this point, you might think, well, squaring anything makes it positive. Like if you do, let's say, the absolute value of 3 minus 5 squared, that's the same as doing the absolute value of 3 minus 5 is the same as the absolute value of negative 2, and that's the same as doing 2 squared. But what if you didn't have the absolute value? What if you just did it like 3 minus 5? That would be negative 2 squared. But negative 2 squared is also just 4. Negative 2 times negative 2 is 4. So it doesn't really matter whether you have the absolute value or not. They work out the same way. So with that in mind, I'm just going to write this a slightly simpler way as just not worrying about the absolute value, just saying x2 minus x1 squared plus y2 minus y1 squared is equal to c squared. And then if you want to find what c is, you can just take the square root of both sides. That cancels out with that. And I'm not bothering again with a plus or minus here because if you're talking about distance, it's always positive. So in other words, this distance that we're trying to find is that this horizontal line here, or sorry, not horizontal, diagonal line, the length of that is the same as the square root of x2 minus x1 squared plus y2 minus y1 squared. That is equal to c. And that is how you can find the distance between any 2 points. Subtract them to get the distance, and it doesn't matter what order you subtract them in. You don't need to deal with absolute value because you're going to square it anyways, and it's going to become positive no matter what. Then do the same thing with the vertical distance. Add them up, take the square root of that whole result, and you're going to get that distance. So this is the distance formula. The distance d between these 2 points, I was using c here, but the c is the same thing as this d, the distance between points, is the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. All right, so the distance formula, you can see, is basically the same thing as the Pythagorean theorem. It's just a couple steps away to go from the Pythagorean theorem to the distance formula. So they're kind of the same thing. Now let's use it to find the distance between these. This is a good place to pause the video and try this one yourself to just see if you can understand this formula enough to just plug in these numbers. This is your x2, sorry, your x1, y1, and your x2, y2. Try to plug in those numbers. I'll take a moment for you to pause it. All right, so here's how to do this. This distance is going to be the square root. I'm going to replace the x2 with 7 minus x1, which is minus negative 5. So that's the x2 minus x1 squared, plus y2 minus y1 squared, negative 3 minus 2 squared. Let's work this all out. We're going to get the square root of 12 squared plus 5 squared. This is going to come out to 144 plus 25. Oh, by the way, this is, again, I should have been a little bit clearer, negative 5 squared. Negative 3 minus 2 is negative 5, but squaring negative 5 still gives you 25. So it doesn't matter. So that gives you the square root of 169, which comes out to be 13. All right, so if you got 13, good job. That is the distance between those 2 points. All right, next we're going to look at the midpoint formula.